Okay, guys. Last lesson was about the lengths of chords. Just a real quick recap. If I have two chords that intersect, all right, what we found out was the following: that if you take the parts, the product of their parts, so CE times ED, it was equal to the product of the parts of the chord that also intersected it. So for instance, BE times AE. Okay, so hopefully we had that concept clear. All right, now we're on to how to find the measures of tangents and secants, the other different lines in a circle that we can measure. I'm going to make this pretty easy for you guys here. All right, the theorem's going to be ready. Whole times external equals whole times external. Okay, so let me use these two diagrams above this to show you what I mean. So the first diagram up here is two secants, AC and AE, two secants. So if I wanted to find the lengths of any of the pieces right here, I go whole secant. So CA is one whole secant times its external part, meaning the part on the outside. So BA. So CA times BA would be equal to the other whole secant, EA, times its external part, DA. All right. Now over here, I have a tangent BA and a secant DB. So now this would be whole secant DB times its external part, BC, equals whole tangent AB. Now watch this, times its external part, which is still AB. So if you wanted to get real fancy, honors level type stuff, you could just say with a tangent, it's equal to AB squared, because the whole and the external part are both the same segment. Okay, so whole times external equals whole times external. That's what I'm going to be using to find the lengths of tangents and secants. Okay, so let's go on to some of our examples here. All right, so for this first one, if your answer is not a whole number, round to the nearest tenth. Okay, so here we go. We got two secants. So here we go. Whole secant. So I'm going to take 15. Everyone see where I got the 15 from, the 5 and the 10, times its external part, 5, is equal to whole secant. Again, it's 4 and then x. So this is x plus 4 times its external part, 4. Okay. So we end up with 75 equals 4x plus 16. Move the 16 over, 4x equals, get out my boy here. So I got 75 minus 16, perfect, 59. Divide both sides by 4. 14 point, it says nearest 10th, right? So 14.8. There we go. All right, we're good there. Okay, here we go. Next one, number 2. Now that is a tangent and a secant. So I know tangent is just whole times external, which is itself. So y times y equals whole secant 11 times the external part, 2. All right. I know it's probably, you guys are in the mindset right now from our chords of going part times part. So maybe you were thinking 2 times 9, but just get out of that habit. That's for chords only. Tangents and secants, it's whole times external. So I got y squared equals 22. Take the square root of both sides. The square root of 22 is going to give me 4.7 rounded to the nearest tenth. So 4.7. Okay. We're good so far. All right, here we go. 2 secants, so still whole times external. So I'll do, let's see. I'll do the easier one. Y plus 8 is 1 whole secant times its external part, which is 8, is equal to, now how do I express the whole secant of the next one? Y plus 10. And then I'll multiply that by its external part, which is 7. Okay? So 8y plus 64 equals 7y plus 70. Move the y's over, I get y equals 6. Perfect. All righty. All right, moving on to number 4. 4 is a little tricky now because you have x and y. All right, you'll have x and y. But here's the thing. Everyone, I'll just highlight it real quick and then I'll get rid of it. Tangent and a secant. So I could do whole times external on that, but what's the problem? You're going to have y times y, and then for the secant, you're going to have something with an x in it. And I don't want to have an equation with a y and an x in it. All right, so doing whole times external right away is probably not the best idea. All right, probably not the best idea. So instead, what I can do is, take a look. Not only do I have a secant and a tangent, I also have chords in there. Look. 2 intersecting chords, right, guys? And then from last lesson, part times part equals part times part. There you go. So 4x equals 32. X equals 8. Okay, so that piece is 8 now. Okay, now I can do whole times external equals whole times external. So let's go back to that tangent. Y times y equals whole secant now is what? 4, 8, and 6. So 18 times its external part, which is 6. Okay, so I end up with y squared equals, I'm pretty sure that's 144, but just to check. Oh, 108. Good thing I did check. One job. 108. Take the square root of both sides. Oh, I know the directions say nearest tenth, but I should have said simplest radical form. That's honors level. 10.4. So y equals 10.4. All righty? All right, so again, I could not do whole times external on the tangent and the secant because I would have had a y and an x, but I do have 2 chords that intersect, so I could do part times part. All right, buckle up for this next one, kids. Buckle up. Well, it doesn't look that bad. All right, we'll see you here at the end here. You're right, it's not that bad. It's the algebra that's going to kill you. All right, so here we go. I got 10 times 10, the tangent, equals, what's the whole secant? Take a look, what's the whole secant? 2x plus 4 times the external part, which is x. All right, let's clean this up. I have 100 equals 2x squared plus 4x. Oh boy, you see something with a squared in it. Like, yeah, buddy, we're going to have to factor. First time in quarantine here, we're going to have to factor. So move the 100 over. I get 0 equals 2x squared plus 4x minus 100. So you look at that, and before I even start factoring, you could probably take a 2 out, right? Divide everything by 2. Make this a little bit easier. X squared plus 2x minus 50. Okay, so that's where we're at right now. X squared plus 2x minus 50. So we could take our time right now, try to figure out two numbers that multiply to negative 50 but add to 2. But we would be here a while because no two numbers exist. So guys, what's our only other option if I can't factor it? You're right, quadratic formula. Yep, quadratic formula. So here we go. X equals, what's your B value up here? What is our B value? I'll do this off to the side. I know my A value is 1, B value 2, C value negative 50. So if the B value is 2, when I plug it into the quadratic formula, it becomes negative 2 plus or minus. I know inside the square root is B squared minus 4AC. But if you remember, I'm always a big store guy in your calculator. Store, store, store. So I'm going to go to the calculator right now with you. And I'm going to store 1 in for A. I'm going to store 2 in for B. And I'm going to store negative 50 in for C. And I'm going to ask my calculator to calculate B squared minus 4AC. And I get 204 out. So 204 divided by 2A. So 2 times 1, which is 2. Okay, so now from here, because it says round to the nearest 10th, the plus or minus tells me I'm going to get 2 different answers. All right, so I go back to my calculator. I get my fraction template out. First answer I'm going to do is negative 2 plus the square root of 204 all over 2. And then the next one, get another fraction template. The second answer is going to come from negative 2 minus the square root of 204 over 2. And you'll notice something with that answer. I don't think I can have that as an answer, right? Negative, so it's what, 6.1 and negative 8.1? All right. Unfortunately, I can't have that as an answer because I would make a length negative, so reject. So my answer here, 6.1. Okay, the setup is not bad at all. We still did whole times external. Look, take a look. We still did whole times external equals whole times external. It was just a little algebra. Okay. Hey, you guys are going on algebra 2 next year. All right, get used to this right now. And then 6, what I'm going to have you do is try that one on your own right now. And we'll get back, pause the video. I'll do the same and come back and see if we got the correct answer together. All right, so go ahead. Okay, guys, here you go. Hopefully you didn't get tripped up on this one. Remember, it's always whole times external, not whole times internal. All right, so you can't use that 4.5 because it was inside. All right, you got to use 8, which was outside. And how did I get 8? 12.5 minus 4.5 gives you 8. So it's x times x, which is your tangent, equals 12.5, the whole secant, times 8, which is the external part. And you get AD to be 10. All right, so whole times external equals whole times external. All right, good luck on the assignment.